Hello everyone. So in this video, I'm gonna talk about how actually we can write the equation of a rational function. So when we have the graph, okay. So it's somehow complicated, especially if you have no background on how to find the asymptote or some of the x and y intercept and stuff, some of the features of the rational function. So it's good to review those if you don't get this fully, okay? But usually, whenever you have a rational function, let's call the r of x, right? And then that is basically a fractional way of writing two polynomial, okay? So let's say we have p of x divided by q of x. So when you divide two polynomial, and that is called our rational function. So our goal is to write the function itself from this graph. So, whenever you have a rational function, and then if your function is simplified or if your function is in lowest term, meaning that if you were able to simplify the numerator and denominator as much as possible, we call that as lowest term. And what makes the numerator is 0 is called x-intercept. So if you look at the graph, so we have a intersection right here on the x-axis, and then this is another intersection. This is 1, 2 units to the left from the y-axis. That's going to be just -2, comma 0, and then there is a 5, comma 0. So these are my x-intercept, but if you like to write as, like if you want to write the polynomial itself, by using those x-intercept, because these are our real zeros, we can write some binomials. So if this is a solution, so again, this has to be a number that will make the numerator 0. So that means one of the expression in the numerator should be x plus 2 to this some power, and then x minus 5 as well. So the reason why this has to be the case, because if you have like, let's say this is y equals something divided by something, if you make the numerator 0, okay, somehow, 0 divided by something will be 0, so which means the y value will be 0. So meaning that those x values that will make the numerator 0 is going to be actually the x-intercept. So which is why we like to use the x-intercept to find the binomials in the numerator. But we need to be careful because in some cases, right here, like at 5, the graph crossing the x-axis at 5, so from one region to the other region, so from negative to positive or positive to negative. So if that's the case, we call this is going to be the place that this binomial should have a odd multiplicity. So this guy should be odd multiplicity. But if you are having a x-intercept where you are actually just touching, not crossing, we are going to say this has to be even multiplicity. So we don't really know, like, is it going to be 2, 4, whatever, but it has to be even. So to make it lowest term, I will go with x plus 2 to the second power, and then this guy will be x minus 5 to the first power. So this looks like okay so far as my numerator, okay? And that is something. And the second thing we like to remember with the rational like functions, whenever you have some vertical asymptote, which is like x equals -5 and x equals 2, those are the x values that will make the denominator 0. The reason why that's the case, because you cannot have such an x value, because if you choose x equals 2, and then if that makes the denominator 0, that will be undefined. So which is why if you look at the graph, my graph doesn't really touch x equals -5 or x equals 2. So which is why that those are the values that will make the denominator 0. So the first value is x -5. To get -5, so I will say that could be written as x plus 5. And to get the x equals 2, I should have x minus 2 as my factor. But I like to be careful as well with in terms of multiplicity of these guys as well. So in this -5, if you go from left to positive, like if you go actually, like if you look at the x value, like if your graph goes up this way, it goes all the way to the positive infinity when you are getting closer to -5. So if you want to name it, we can just say when you take the limit, when x goes, like x approaches to -5, but we are approaching -5 from the left side. So if you just go this way all the way to up, so you are approaching from left, and then we use this minus on top of that 5, meaning that we are approaching -5 from the left side. And I'm gonna say this is r of x. So if you are approaching -5 from the left side, your y value is getting bigger and bigger. So that is gonna be positive infinity. So that is something. And if you do the same thing with the right side, which means if you are, let's say here, so if you are approaching to -5 from the right side, your y value is actually getting smaller and smaller. So the second case, if you just go from the right side, so you will get negative infinity. So if you are getting two different signs at a like vertical asymptote, so which is positive infinity, negative infinity, that means this is gonna be our odd multiplicity. Okay, so that is why x plus 5 should have a odd power, so 1, 3 or something, but we will go with the lowest terms, so x plus 5 to the first power. But if you look at the second one, which is x equals 2, right? So if you approach this from right, so if you just approach this way, so your y value is getting smaller and smaller. If you approach the 2 from the left side, you're actually getting smaller and smaller as well. So y value in either side of the 2, when you get closer to 2, it's gonna be negative infinity. So let me actually write those. So when you take the limit as x approaches to -5 from positive side, okay, so I'm gonna say this is r of x, that was -5. And if you do the same thing with this guy, so the limit as x approaches to 2 from positive side, okay, so if you approach the 2 from positive side, your y value getting smaller and smaller. So that is negative infinity. And if you do the same thing with the other side, when you take x approaches from left side, okay, so the r of x is also getting negative infinity. So since both are these two are in the same sign, so both approaching to the same with the negative infinity, so we are going to say this guy x equals 2 has to be even multiplicity. So meaning that the power of x minus 2 should be at least 2. So something like this. So we have this one. But at the same time, you know, whenever I take the zeros for the numerator, I got the x-intercept, which is good. When I take the zeros for the denominator, I got my vertical asymptote, which is nice. But at the same time, there's something else, you know, which is our horizontal asymptote. And that is given as y equals 2. We have to use that information to get something else. So I'm not sure if you remember, but this is basically when you're gonna take the like this fraction and divide by this fraction. This is the line you are actually getting close to. But how this is gonna possible? So you can just if you are getting a 2, y equals 2, when you get x is like huge x values. So if you expand this, you get x to the second power times x to the first power. So the largest power will be x to the third. And the same thing, x times x squared, which is x to the third. So when you multiply these guys, and then you get x to the third as the degree of the numerator and denominator. So if you choose x to be very large values, so you should get all other terms other than the x cubes will be something you can actually ignore, because when you choose x as big, so the x to the third will be way bigger than the other terms like second degrees or first degrees. So which is why when you take as x approaches the positive or the negative infinity, this fraction should be getting closer to 2. How this is going to happen? So that will happen if your numerator is like 2 times x cubed and denominator is just x to the third power. So again, you may have some other terms, but it will be kind of pointless to consider those other terms, because when you take a number to the third power, if that number is big enough, then the other numbers will be not big deal. So, and if you have this, and then you can say these will cancel, you get y equals 2. So if you want to get y equals 2 as your horizontal asymptote, so the numerator, the coefficient of the highest degree, should be twice as much of the denominator. So since we are told this is going to be in lowest term, so I should have 2 right here, and then maybe 1 here, which will be our final answer. So I hope that makes sense. By using our intercepts or asymptotes and stuff, so we were able to get this equation. So if you really want to make sure if this is the case, you can go ahead and plug these in any calculator and see if this graph is something what you have. But I think you can double check on your own. Okay, so that would be our final answer. So I'll see you next time.